Hey Dennis,
Yes.
I am here today with the handy flip cam to talk about server load balancer testing because we have a new methodology that's coming out. So I had a few quick questions for you. The first being, what are you looking for when you're testing server load balancers?
As if you were a network guy and you wanted to deploy
Let's
them.
take it from the kind of the user's perspective, the client's perspective.
So performance, making sure it meets your needs and that it can scale so that it has some life in it. You don't want to deploy something that's dead in the water. Reliability, you don't have to crash. Don't forget, load balancer crashes. Everything behind it is inaccessible, just like Gmail, a good example of that, or any other outage. LinkedIn the other day. Load balancers go down, they can ruin your day. I would look at security, making sure that it doesn't have any data leakage, because when you have a load balancer and it aggregates so many connections, a lot of times they'll aggregate connections and do one connection back to the server to speed things up, and they leverage the caching. You have to be careful with that there isn't hijacking cookies that work just for the load balancer's sake. Compatibility between browsers, how it handles, of course, large amounts of connections that may not be all of the same server, how it can split tasks up, different applications, because nowadays there's lots of different applications. So I would look at how it does mail and how it does database traffic, because nowadays the servers aren't getting much faster. I mean, they are, but they're actually, the virtualization are kind of getting a little lower, and you want a load balancer to shed that load. So all those things, and manageability, of course. I think all the things, maybe even manageability, all fit on the term network resiliency. That it's resilient. That no matter how much good or bad traffic on it, no matter how good a business day or bad business day, or who woke up on the bad side of the bed, the wrong side of the bed, it's going to work. So that's where it is. It's resilient. Making sure that it works.
Sure. Very important. In terms of the actual testing that you would go about doing to get to all of those things and figure all of those things out.
So load balance, other than the normal stuff, read the methodology, all your performance, your session RAM. The big one I pick on for load balance is reliability and compatibility. Those are the two that I think are ignored, heavily ignored. Everybody counts on HTTP to do their load balancing because that's what they're used to, and it's kind of the model of testing that even the manufacturers of load balancers go to. But when you really think about it, people deploy them in such a critical spot because this is where all the resources are, and to deny people access to it is amazing. That's just huge. And so compatibility, I would look at in terms of browsers. A lot of them do tricky stuff. They make sure they don't do keep alives on the servers, or they'll make sure the client ends a connection, and all these different things that can leave your state table in horrible trouble, or the way it gets things, and they may depend on how a browser works to get performance out of them. So I would check that. I'd also check how much data you have to get in the back end, because they do use caching heavily to get the performance numbers. So check it, make sure that you don't blow out your cache, because as soon as you blow out your cache, you're in a world of hurt. So compatibility is a big one. I haven't found a load balancer yet that doesn't require some tweak to something somewhere to make it run optimally. And that may be the load balancer itself, a switch, or router, the browser, the server software. Reliability is a huge one. I haven't found a load balancer yet that you couldn't do protocol fuzzing on and crash it. And that's obvious every day. I mean, we wrote that blog post about Cisco. I was being a little sensational there on purpose, but the majority of those were denial of service attacks. A crafted packet crashed that router or switch or that service. That's damning. That's just as bad as being hacked. If someone denies your service and you can't run your business, you're down. Maybe stealing your credit card is a lot worse, agreed. But being down for a Dell or an Amazon or a Google, that's life-threatening. The only one that I think can go down a lot is Twitter, because everybody likes a little fail well. Otherwise, you're not supposed to go down.
Right. All right, so why is it happening more and more? Or does it just seem like it's happening?
No, it's happening more and more because, one, you have even more browsers in the marketplace. You got Chrome, you got Safari. They actually have a good percentage of user base now. You got the iPhone, BlackBerry, everybody's going on the web. So guess what? The browsers are all acting differently, and these load balancers are getting in the way, and they think it's their way or the highway. Same thing with proxies. They have the same problem. They believe traffic should only look like this. But you don't know what the real world looks like, and you have to use real application traffic. The other thing is, there's a lot more applications behind load balancers now. It's not just load balancing the web. You may be load balancing database requests. You may be load balancing your mail. You're definitely load balancing your mail if you're a big company with Exchange and different things of that nature. So, yeah, it could be lots of things that you're trying to get to. So, and they're not really good at that. They don't have the specialized support like they did for HTTP. You'll see that a lot of load balancers where the management is great for HTTP, but it's horrible for the other protocols. You see a lot more encryption in place, which slows down the load balancer. So if I send too many encryption requests, does it slow down my other requests as well? So you have to look at that. And the crashes, of course, is people are, the down economy, the first people to go are QA people, and so that kind of stuff happens as well. And they're not really dotting the I's and crossing the T's. And the performance numbers are so high, it's hard to test real application traffic and send the bad traffic at the same time.
And so, all right, so there's the unique proposition that BreakingPoint Elite brings into
there you go.
Right? The realistic applications and the high performance. What other type of maybe in the weeds functionality within Elite do you like to use for server load balancer testing?
The stack scrambler is an important one. Changing states and protocols is a good one. You can use the superflows, and you can edit them so that you can put the response before the get and an HTTP request, which is backwards. And you can do, for example, after the mail client closes, continue to try to retrieve mail. You'll really break a lot. I know it sounds like, well, that doesn't work anywhere. Trust me, on a load balancer, they probably don't have a full state machine. They're probably tricking it, going, I assume the next state should be this. And that's how people steal cookies and steal pieces of data and hijack your session and jump on you because they can do that. So yeah, that's a common one. That's why we do that. That's why we allow you to change the protocol up, and it still works. It's still the full protocol, so it doesn't matter. Mm-hmm. You can put the SMB negotiation beforehand. It'll connect. It'll work. It won't work with 2008 Windows because it'll block it, but it'll work with the load balancer.
Right. And all that stuff is in the test methodology. So
yeah, hopefully
I encourage people to read that. Well, thanks for your time.
Sure.
Right.